Welcome to Sairam Tribali YouTube channel. Let us discuss Module 1 representation of power system components. In that we have equivalent circuit model of a synchronous machine, right? Machine, either it may be a generator or motor, right? So generator which converts mechanical to electrical, AC here. So motor which converts electrical to mechanical, right? So here we have a non-salient type, particularly they mentioned. So we have two types of synchronous machines. One is salient pole type and then non-salient pole type. So based on the rotor, keep it in your mind, because they're classified into based on the structure of rotor. So we have a salient and non-salient. Salient is having a large diameter, small axial length, and then non-uniform air gap will be there. It's for load speed applications around less than 500. So we can find the salient pole type synchronous generator in the idle power plants, because the speed will be less, right? 0 to 500. I mean, the Pelton wheel is coupled with the synchronous generator. So and non-salient pole type of synchronous generator using in thermal power plant, nuclear power plant, gas power plant, because the rotation is more, right, in the thermal, nuclear, gas power plants. So there we are using a synchronous generator, also called as a turbo generator, right? And another name is there, alternator. Synchronous generator or synchronous machine also called as alternator. So why? Because it produces alternating voltage, alternating current. And also we can define like this: whatever the rotation will be there, right? I mean, the synchronous machine rotates at synchronous speed or constant speed. So it's called as a synchronous generator basically. So whatever rotation will be there, right? That rotor rotation, that is directly proportional to the output voltage. That's why it is called as a synchronous generator or synchronous machine. So constant speed application and synchronous speed application. So already we know, right? Synchronous speed is ns is equal to 120 f by p. 120 is the phase angle placing of that stator armature conductor, and f is the frequency of the output voltage if it is generator. If it is motor, is the supply voltage, right? So synchronous machine, either it may be a synchronous generator and synchronous motor. If it is synchronous generators, we have to get supply from the generator. If it is motor, we have to give a supply to the motor, then only it will rotate. So that's a basic concept. So here synchronous generator, how it is related to power system, right? So the basic question, basic knowledge you should have actually. Synchronous generator we are using particularly in the power plants for power production around 11 kilovolts in India. So there we are using a synchronous generator. And also I can give another one example where exactly we are using alternator or synchronous generator in the daily basis, I mean daily usage. So you can see hybrid car like diagram or block diagrams or hybrid cars. There we are using a synchronous generator or alternator, because the engine, whatever reservoir will be there, so petrol engine or diesel engine, there is an engine present. So 4-stroke engine or 2-stroke engine, whatever it may be. So engine gives mechanical output, right? So that mechanical output is coupled with generator, I mean synchronous generator shaft or alternator shaft. So alternator is required, input is mechanical and output it will gives electrical. So why we are using inside the car? So just to think. So hybrid car which operates two sources, one is engine, another one is electric, right? So alternator gives, or a synchronous generator in between it is connected. So there is a induction motor is present, three-phase induction motor. Three-phase induction motor which converts electrical to mechanical. How I mean where exactly input is coming from the three-phase induction motor? From the alternator it goes to a motor, three-phase induction motor. After that it will I mean motor will rotate and then car will be moving. And also for charging of your battery inside the car, because electrical usage will be there, right, inside the car. So that purpose also we are having a synchronous generator, right? So this is a basic concept we can see. And also you can find alternators like generators in your the best example, not only alternator, we are using DC generator also there in your bike. If suppose the bike you people are not at all using around 40 to 50 days or 1 year, So that just idle for 1 year. What happens inside the bike? That battery will be there, right? That battery will dry, right? So after 1 year or after 20 days, 30 days, so you can start the starter button. It will not start. I mean, it won't be starting because the battery will be dry. And after that, you move or by using kicker, you move another 1 kilometer or 2 kilometer. So automatically it will get charged, right? The battery it will get charged. So there also you're using just to use your common sense, right? So next move on to the topic which is related to your power system. So alternator or synchronous generator, synchronous machine, we have a three-phase star connected winding in the stator, right? Like this. This is the slats present over here to folding the stator armature conductor, right? So next there is a these are the armature conductor. Armature conductor since these conductors. It is connected in star. Keep it in your mind. So we have two types of connection in three phase: star connection and delta connection. Delta connection is for only transmission purpose, and star connection is for transmission as well as distribution purpose in the uh, transmission lines. Okay, in the power system, and also in the generator also we are using this type of star connection and then delta connection system, right? So uh, star is having more advantage, right? So because we can use as single phase also, and delta only transmission purpose, but current will be more in the delta. Keep it in your mind. That's a major role in the electrical power system. But star we have IL is equal to I phase, but you will not get IL is equal to root 3 I phase delta, right? It looks like a star structure, that's why it is called as a star. Keep it in your mind. If it is delta, you can draw like this delta, and you can draw like this, and it should be looks like a delta connection, right? So let's see the connection. There is a rotor present. Just to construction you must know, right? Because power system having a generating station as well as transmission as well as utilization and distribution also. So in this generation part we have a synchronous generator, right? So here there is a mechanical input we are giving, okay, like this. Is a turbine present. When turbine start rotating, what happens? This stator armature conductor cuts this rotating magnetic field, but excitation we have to give. One plus minus supply we have to give because for excitation of field winding, okay, but we are using only one small DC generator coupled with alternator or synchronous generator. So just for excitation, if you give, rotate like this turbine, just to consider there is a idle power plant, water is falling like this, and turbine start rotating. So generator rotor start rotates, and field winding also rotate like this, right? So when conductor present in the stator slot cuts by this rotating magnetic field, what happens? Induces in three phases. This one and this one and this one, right? So this is a construction of synchronous generator. How exactly we are using in the present power plants and power generating stations, and also it's having more advantage, okay, because if you consider DC generator, there is a commutator present, there is a brush contact drop will be there, commutator which collect the current from armature conductor. There is a several components available in the DC generator, but here there is nothing is there. Here there is armature conductor, here there is a magnetic field is rotating, just it is rotating like this, and also large conductors you can place. So in the DC generator we cannot place large conductors. Here we can place large conductors because to induce large voltage in the synchronous generator, right? So because three phase voltage we are getting, so that's why we are getting 11 kilovolts in the power plants. Keep it in your mind. So there we are using particularly synchronous generator. See here there is a resistance and reactance is present. This one is a resistance in the R cable. I'll just name it as R A. Okay, ABC I'll mention. Okay, ABC. There is an armature conductor present in the stator. That conductor names as ABC. So why it is R and then L will be there? R is the resistance of the conductor. Even copper is having a resistivity, right? Resistance will be there, and this one is a reactance. If suppose number of turns will be present in the stator, what happens? It acts as a coil, or number of turns becomes a coil. So if suppose this coil or conductor cuts the magnetic field, what happens? Induces EMF in the output side, right? So this is a C conductor, and then this one is a B conductor. See here, EA is the induced voltage in the A conductor, EB is the induced voltage in the B conductor, EC is also induced in the C conductor. If it is balanced, keep it in your mind, it must be all the conductors are placed 120 degree apart each other like this. Okay, 120 degree. Here 120, here 120, here 120. This conductor induces EMF VR or VA, VB, VC. All the conductors are placed 120 degree apart each other. It's a balanced, okay, balanced, because phase angle must be same and then impedance must be same. If it is unbalanced, that phase angle must be not equal, and then that impedance also not equal. This ZA, ZB, ZC impedance must be not equal. That becomes unbalanced circuit, right? So this is the overall construction of and an overall working of a synchronous generator. So once you visit power plants like hydel, thermal, nuclear, or gas power plant, whatever it may be, so there will get generating generator, synchronous generator. So it occupies almost 60-40 site. So in the stator periphery, 100 members they can stand, and rotor is having like it's a big generator, and it generates more voltage. So that's a concept. uh, Particularly why they kept this synchronous generator or synchronous machine in the power plant, in the sense it produces AC. I think you might have got a doubt why, sir, DC is not placing in the power system components, or power system they are not mentioning here, because whatever we are generating always AC, keep it in your mind, not DC. But we are transmitting the power, okay, from the power plant to substation. The HVDC also we are transmitting, right? So there is a rectifier and inverter we are using in between. There also it is possible, but always we are concentrating in the power system component, synchronous generator, and in the generation side. And transmission side we have a T module, and then pi modules will be there. And there is a based on the kilometers we are classifying into three different types of transmission lines, like long, medium, and short transmission lines. And next there is a distribution side, there also we are using a transformer. It's a one-to-one connection, okay. And this one is a representation of power system components of synchronous generator. There is a only one resistance and then one reactance. Total is a synchronous impedance, and then EG is the generated voltage, and then IG is a current for the